a show, some kind of documentary, I forget what it's called, but
I believe we last left off with circular motion? No, we didn't get that far.
No, we learned about like kinetic friction, static.
So just
we just finished lab 4. Or we're about to turn
Which
it in, actually.
we did, Box on ramp.
I'm not turning it down. I'm not turning it
We haven't done box on ramp with friction.
Wait.
We've done box and ramp, but we haven't done.
All right, let's start out there.
I was in that team too.
Lab 4. This one. With the muzzle velocity.
Ooh, we got box on ramp.
All right, so box on ramp with friction. The symbols I have up there are, that's the coefficient of static friction and the coefficient of kinetic friction. And so when faced with a problem like this, the first thing is you need to figure out, you're going through the Massad's method, but you need to figure out, do we have enough in order to break the static friction, to overcome the static friction? So just go through the process. Force diagram. Really only care about the mass in this, but if you want to do the full thing with the ground, why not? Oh, what the heck? We haven't had that test yet. So what are the forces?
Normal. Oh, wait. Can you put on F-Talk? Yeah. So we have normal, gravity, we don't have tension, but we do have friction.
Which way is normal going? On what? Are you going at an angle?
Yeah.
Okay.
At an angle.
So I got normal there, I got normal here. Okay, which way is gravitational force going? Or the weight? Okay. And friction.
Yeah, that's going this way.
Okay.
It wants to go this way. Well, unless there's some defiance of gravity, but.
We assume not. All right, that's the part that I care about. What comes after force diagrams?
Acceleration direction.
All right, which way will it accelerate if it does?
Down.
Okay. Now what?
Now we work on our coordinate axes.
How do you want to set those up?
I don't really care, so someone else.
I would recommend one axis in the direction of acceleration, but we don't have to. You can do it the hard way.
I noticed you didn't put a vector sign on the acceleration. Is this?
The magnitude is A and it is in that direction, so.
So vector is an arrow? It's not.
That's the
a scroll.
direction of the. I guess we, technically that.
Oh, see, that was physics.
So we set up a coordinate system how?
I had J hat.
You want to do horizontal,
No, we
vertical?
don't. No, we don't. I veto that.
What's
My
wrong with
hat
that?
should be the direction of A.
It should be like this.
Yeah.
Good. You can do it that way, Robin, but I sort of view it as quadrupling the amount of math you have to do.
It's just easier.
Okay.
You end up with
I
a
meant
quadratic, and
if it had not been tilted, it would have been J hat I hat, but it is tilted, so J hat, I hat.
Okay. All right, so we have that, so what's next after coordinate axes?
Decomposition.
Yeah, do we need to break any of those up?
Weight, gravitation.
Eva, what are you saying? What did you say?
Oh.
Go ahead, Eva.
The weight, the gravitational pull.
Okay.
We need to decompose that.
Okay, so break the weight up? Is that- Okay.
Yeah, that's what I was trying to.
All right, we've gone through this. So we have normal force going this way, we have friction going this way, we have the weight times the sine of theta, where this angle down here is theta, and weight times the cosine of theta. I'm pretty sure we have done that before.
That's
Okay.
D.
Yeah.
Pardon?
That's D.
Yeah, that's the decomposition bit. My recommendation from a communication point of view, when you break it up, don't put the components into the same force diagram as what you have right here. Don't add the W sine theta, W cosine theta here. Because as I'm grading it, I'm thinking, okay, do they have weight down twice, just once in components and once without, or, you know, I'm trying to figure out what you were thinking if you put them here. So that's one reason I draw it separately.
Oh, okay.
What's next after we decompose?
We do the equations of motion.
All right? And how many equations of motion will there be?
Would we have?
Why two?
Because, I don't know the reason, 2 dimensional,
Yes,
yes.
one object, 2 dimensions for it. Yep. Okay, so the template, F equals ma. I'll have an I hat equation and a J hat equation.
Weight. Is it weight sine theta? I don't know.
All right, so when you're doing this, we're looking at some of the forces in the I hat direction, I hat and negative I hat. What are all the forces in the positive I hat direction? Looking at this right here, I hat's this way. What are all the forces in the positive I hat direction?
Weight sine theta.
All right, what are all the forces in the negative I hat direction?
Friction.
Minus friction
Oh.
equals.
Mass times acceleration.
Yes, mass times acceleration.
Okay. And the other one?
Weight cosine theta. No, I lied. I'm sorry. Normal contact minus weight cosine theta. Okay, maybe we should just. Because it's because wait, actually. Dr. Fox, can you
Yes.
explain why you chose which is cosine and which is sine for the weight? Like, why is it not switched?
Because the math people, they made me do it. All right, so I'm breaking weight up. Whatever I'm breaking up is a hypotenuse of a right triangle. I know one of the components is along the line of the ramp, and the other one's perpendicular to that. That is a right angle. So I need to figure out what that is and what that is. So this angle here is theta. If this angle, and that's a right angle, so what is this angle?
90 minus theta.
All right, which I'm gonna label as theta prime. This is a right angle also because weight is down, is perpendicular to the ground. So what would this angle here be?
Theta.
So if I look at my original right triangle there, this is opposite of that angle, so this is the sine.
Oh, okay.
Stephanie?
In what scenario would the opposite side be theta?
If it's that, I gave you this angle. So if I've given you the ramp like that and given you that as theta, then cosine theta would be down the ramp, and sine theta would be into the ramp. Because as you break it up, this is the adjacent to theta. So this would be the cosine, this would be the sine. Did that, okay.
Yeah.
Other questions? My glasses are filthy. Thank you. Oh. All right, well, we haven't finished that equation over there. An equation has an equal sign or an inequality sign, and it has something on both sides of that. We are missing the right-hand side. Oh. Thank you.
I'll leave it out for you.
In the future. Thanks.
Mass times acceleration.
Like that?
Like, yeah.
All right, if this is true,
Okay.
what Maram is claiming is that the acceleration in the I-hat direction is the same acceleration in the J-hat direction. In other words, if I've got an angle like that, it's gonna be shooting at a accelerating at a 45-degree angle because it's got components, equal components in both of those directions. In which direction is the acceleration? So what is the acceleration in the J-hat direction?
Zero. I was just joking, you know?
Oh, sorry.
It was for teaching.
Can I just take it?
Yeah, I wanted to like teach everybody and stuff like that.
And I apologize, this really is funny.
I carry it around for myself and everyone else.
This is a good video. It's gonna blow up. Oh, it's this class. Okay, so now what's next? We got our equations of motion. And again, one of the purposes of setting up our coordinate system the way we did is so that one of my equations is going to be equal to 0.
Okay.
So what comes next after the equations of motion?
Substitution.
I assume that's what you said. Why not?
Sorry.
You're always tired.
All right, so for what do we have an independent equation? And when I say independent, I mean an equation that we can do a substitution for that has nothing to do with this problem. It's always going to be true.
Repeat that.
Weight.
Yes, we have a formula for weight. What is the formula for weight?
Energy.
Yes.
That sounds gravity.
Ooh.
Gravitational force.
Weight is gravitational force. What is a little g?
Force of gravity.
No.
I got this.
Little g doesn't have units of newtons or anything like that. What is little g?
Due to
Acceleration.
Force and gravity.
Say it again?
Acceleration due to force and gravity.
Okay, or just acceleration due to gravity. Or gravitational acceleration, if you want fewer words. I usually say acceleration due to gravity. All right, so our first equation becomes mg sine theta minus, all right, we do have an equation for friction. We don't know if this thing is actually going to slide or not. So, which friction do we use?
Static?
Yes. First, we have to establish whether it actually is going to slide or not, and so we stick in our maximum static. And that's equal to ma, and the other side, we have y equals mg cosine theta. And yes, I substituted and brought that term over to the right-hand side. Now what? What comes after substitution?
Solving.
All right. In theory, I know what theta is. Mass, I really don't care about. G, I'll know mu. My unknowns are the normal force, and acceleration. So I have to get rid of one of them, so I'm gonna take this and plug it in for y. So I have mg sine theta minus mu s mg cosine theta is equal to ma. Is there anything to do to simplify this?
Divide by mg? No, wait, that's not equals, that's minus. You could divide by mass.
Yeah. So I didn't give you the mass, actually I didn't give you anything, but there's a number of problems where I don't give you something like the mass, and sure, I've said it before, either I've made a mistake, or you don't need it. If you want it, if you're not sure, you can always come up and ask. Usually from my reaction, you can tell if you need it or not, as in, oh, I made a mistake, or, sure, how about, you probably don't need it. Some people are not comfortable with the vagueness of, you're gonna cancel mass out at some point. So if in doubt, and you don't need it, but, well, in theory, you don't need it, but you personally at that moment need it, make up a value that's not 0. I recommend 1 kilogram. But anyway, we divide the mass out because it's a common factor to every term. So now we're left with our formula for acceleration. Our acceleration is g sine theta minus mu s g cosine theta. So now let's plug in some numbers here. Let's make the angle, let's make that 37 degrees. Let's put this on Earth, 1. So little g is 9.8 meters per second squared. And mu sub s is already given. So what is the acceleration? This is a calculator exercise.
My calculator's not on.
G is constant in this case.
We assume it's somewhere around, it's 9.8 meters per second squared.
Alright.
Somewhere around 2.8, but nothing something more precise than really.
I think it's 9.798 or something.
Oh, I was thinking for the acceleration. What you got, Stephanie?
I got 5.578.
Is it 37 degrees over there? No, I'm not buying that. Did you forget to multiply by 9.8 for the second term?
Yes, I did.
Oh.
767.
2.761?
67.
How do you put the how do you put the friction sign in?
Sorry, one thing at a time. 2.67?
767.
767. Units.
I don't know.
Meters per second.
Oh, obviously. It's
All right. The mu symbol, the symbol right here, it's like you're doing the letter U, but you put a spin
Yeah,
off
I
on it.
know, but how do you put that in? Is there a value for that?
No, it's the value for it. I put it over here. U sub S is 0.4.
Oh, okay, thank you.
Yep. All right. So, what is the acceleration of this mass?
Acceleration is only positive, correct? No, wait, that's wrong. I'm still getting it down, I'm sorry.
So we change it. Is the acceleration of this mass
Because I know the
2.767
velocity
meters
is
per second
this
squared?
way, so
Yeah.
probably.
Yeah, it is. It is.
Why?
Because, as you can tell from the board, we were using, does anyone else want to add on? It is, right? Isn't that what we were trying to find the whole time?
So we were trying to find the acceleration, but is that the acceleration? Are we done with the problem?
I feel like we need to know something. Do we need to use kinetic friction?
Yes. All we've done at this point is establish that it is going to slide. Our acceleration is in the direction we expected. We do have enough to overcome static friction. Therefore, we have to take the problem, the next step of figuring out what the acceleration actually is. All we've done is establish it's going to slide. Therefore, static friction is not appropriate. That's now okay. We should get something bigger than 2.767. Probably not a whole lot bigger. So that's roughly 6.